Hey guys, welcome back. I'm so excited for today's tutorial. So we're going to be actually looking at building customer churn prediction system. The reason I'm so excited is because we're going to cover like a lot of components like in the data science lifecycle, right? Starting with data cleaning, then doing exploratory data analysis. Then we're going to look at feature selection, feature engineering. Then we're going to actually build our model. We're going to look at tree-based model, SGBoost, random forest, and we're going to evaluate our model after then and we also going to be looking at model interpretability because that's very important, right? For we can think of our marketing team, they might want to understand why these customers leave, right? So that's very important, like for business use cases. And we're going to actually deploy our model with Plumber API. And the last thing that we're going to do is to build this user interface so that the marketing team can now actually log into the system and actually be able to see which customers are most likely to leave and take necessary action. Okay, so this is a very powerful project. Make sure that you get your pen and paper because we're going to cover a lot of things, right? So before we move on, I thought it would be a good idea to kind of like show you how this thing works, right? What's the end goal? What is it that we're trying to build? So let's say that I have a customer ID here. So I can say get prediction. So we can see that so for this customer, the machine learning said, yes, this customer is going to leave based on these parameters, right? Like these parameters refers to their contract, their tenure, how long they've been with us, their total cost, how much they're paying per month, their internet service, it's fiber optic or is FBS. So all of these things, right? So one thing that you can think of this is that the system is not only telling us that the customer is going to leave, but it's actually helping us to prevent them from leaving by playing with these parameters. So you can think of now, these parameters are going to help us to negotiate with the customer to give the customer a better option in such a way that we don't get to lose them, right? So let's get it. Let's see how this customer churn prevention work, right? So I can say get prediction so that I can see the probability of them leaving, right? So we know that they were actually going to leave, but I just wanted to see the probability. So the probability is 71%. So that's very high. How can we then reduce this probability? So let's play with the internet service. So we can see now they're using fiber optic, right? So let's see if they were using DSLR, right? So let's say get prediction. Wow, look at that. So it went to 48%, right? And we can actually try to negotiate with the customer. Maybe you can think of, we can reduce their total cost, and we can say, okay, how about we reduce your total cost? But if we then give you 1 year contract, right? So what will then happen? Let's see, let's get the predictions. Look at that. So now it is 32. So we moved from 71% to 32%. So all of these features are very important as we're going to do EDA and just trying to understand the data. You will see that actually this is true because customers who likely to sign long contract with us are more likely to stay, and all of these information, you'll see how they are correlated with the target. Okay guys, so this is a very powerful tutorial. I'm so excited. So let's get into RStudio and start building this system. Cool. Before we start, one thing that I want to start doing is to actually try to zoom in into RStudio. So I'm just gonna say tools, global, and we're gonna say appearance so that you guys can actually see it. Let me just say 150 and apply. Okay, perfect. Cool. So let's start with reading our data and just gonna go and read our data and start exploring it, right? So I've just loaded all the libraries that we're going to use. Let me just do this so that you can be able to see. Perfect. So, by the way, just to give you some context, so this is a telecommunication Churn data set, right? So the data set contain of 21 column. So like columns such as gender, senior citizen, partner. So you can actually cleanse the view. You can actually cleanse the data by going here. So if you can just click here, you'll be able to see the data in a more clear manner. So you can see the data now. We have dependents, tenasia, multiple lines, internet service, online security, online backup. All of these features are actually going to help us to predict if a customer is going to leave us or not, right? We have contract, paper billing, paper method, monthly charges. Okay, so you can see that I actually have divided all the files according to data science lifecycle, right? So I've started with data cleansing and EDA. So we're gonna look at feature selection and engineering, pre-processing, hyper-tuning, train and evaluate, and model interpretability. Okay, so I'm going to post this code on GitHub so that it's easy for you to kind of like follow along. That's why I've divided all the data science lifecycle into files so that it's easy, right? So cool. So the first thing that I want to do is to look at the number of missing values, right? That's very important for us. But there's a library that we can use. It's called schema. It's kind of like helps you to kind of like glance at the data. So it's very useful because you can look at the distribution of the numerical data. You can look at the things such as like mean, standard deviation. So it kind of like gives you an overall of the distribution of the data. You can see that actually total charges is skewed. Also, you can look at the categorical features, and you can look at the number of missing values. So you can see that we don't have missing values here because we just removed them. Yeah, you can look at the complete rate. So this is a very nice feature. I really like this library schema. So you can just use it and check it out. So it's like we have cleansed the data. One thing that I've realized with the data is that it was actually inconsistent, right? By inconsistent, I mean, so some of these columns were named like no phone internet service, then they were named no. So I just decided to kind of like be consistent, like just to have no and yes, right? And just remove this no phone service because it's just anyway, it just means no, right? This is just part of data cleaning, just so that we are consistent with the data, you know. So I'm just gonna do that. Let's just continue. And then I'm just gonna do schema just to look at the data again after I've just did those small changes, right? So after, what you wanna do is that you wanna write your clean data to the folder. I've already done that, so I'm not gonna run this code. Okay, so now we can start with our EDA just to understand the data, just to understand what's going on here. So we're just gonna look at the gender distribution, right? Let's plot this. Okay, cool. So now we're actually looking at gender against the target. So what we say here is that between gender, like between female and male, who is mostly like to leave the company? Okay, I know that in some countries this is illegal. You're not supposed to use such data to kind of like predict you know. So it's very important, like as a data scientist, to kind of like understand data governance in the company, you know, so, and regulations. So I believe that in some countries this is illegal, so you're not supposed to use like gender, because you might it's wrong. Then that means your model might actually say female are more likely to churn or something like that, right? So you shouldn't use such features like also like race, something like that, right? But for the sake of the tutorial, let's just keep on going, okay? But just keep that in mind. And you in the company, you can ask data governance team, something like that, and maybe understand if like is this allowed. So okay, cool. What we're gonna be looking at now is actually gender, like right between male and female, who is most likely to leave us. Based on the data, we can see that actually the distribution is fairly equal, right? So pretty much this doesn't say a lot to me, because you can see that for customer that did not leave, we pretty much have equal distribution. Also for customer that left us, pretty much is the same, right? So there isn't too much information. So let's look at partner distribution. So what we're saying here is that customers who have partner, are they most likely to leave us? So what we're seeing here is that for customers that did not leave us, we can see that if they do not have a partner, then if they have a partner, then we have a high distribution, right? So maybe having a partner, that might mean that the customer is not going to leave, because we can also see here on the churn. So customers that left us, we can see that the no is greater than yes. So which means that so if someone does not have partner, they might leave, right? So this is based on the data. I don't know how true this is, but don't worry, we're going to use some statistical techniques whenever we're doing feature selection. So cheat test and all of those things, so that we make sure that we are accurate. So let's look at dependent distribution. So this dependent distribution is quite tricky, because I can't say it's pretty much explaining the target, because when you go on the yes side of things, you can pretty much see that for customers that did not leave us, so we have the same distribution for yes, they going to leave us, and no, they did not leave us, right? So I'll also say dependent is not actually explaining that much. So let's look at tenure, how long the customers have been with us, right? So this is quite interesting, right? Because we can see that, so if you can look at the first month, you can see that actually the customers are more likely to churn. So which means that if like you on average, maybe let's say for the first 18 months, they are most likely to churn. Then as you go on to like, if the customers stay for like on average, let's say 35 months more, then they're not going to churn, right? So that means as a marketing team, that's why you must make sure that you try by all means to keep the customer for longer, because they're not going to leave you, right? We can see this density here. So let's try to look at data from different dimensions, right? So like just to look at it from different angles. So what I will do, because I just want to create a huge plot so that we can all see, I'm just gonna paste it here, and I'll just zoom in. Okay, perfect. Let's zoom in. Cool. What am I doing here? So I just want to look at customer tenure, monthly charges, and average monthly charges by contract type, right? So let's take a look at average customer tenure. So we can see, like I said, on average 18 months. Yes, they're most likely to leave. So if your customers stay for less than 18 months, yes, they are most likely to leave. And for no, they must not leave. So just try to make sure that you keep them at least for 36 months, right, with you. Just make sure that the more you keep them, then they're not gonna leave, right? So that's a good thing. I think this feature is going to help us more, because it's kind of like explaining the target very well. So let's look at the monthly charges. I'll say we expected this, right? So the more monthly charges we have, then we are most likely to leave, right? So, and the less monthly charges you have, then you're most likely to stay with the company, right? So that was expected. So let's look at average monthly charges by contract type. So we're looking at three dimensions, right, guys? For some of you, this might be confusing, but what we're saying in simple terms is that we want to look at the contract type. On top of that, we still want to look at the monthly charges. On top of that, we just want to see the churn, right? So the first one here, we can see that from month to month, whenever the charges are 73, yes, they are most likely to leave, and they are not gonna leave for month to month when the charges are 61, right? Or less. So just keep that in mind, right? So for 1 year, we can see that I can't see the specific value there because of the plot is quite huge, but we can pretty see the same thing, right? For 1 year, 2 year, so you can see that the years is consistent and the distribution is quite consistent. So let's go to another plot and just we're gonna go to the interesting stuff, guys. Just stick with me for now and let me just walk you through the EDA portion, and we're gonna cover a lot of interesting stuff as we go on. So let's just zoom in just to understand this plot. I'm just gonna remove this. Perfect, right? So what I'm doing now is just like I'm just trying to understand churn by contract type. So we can see that actually month to month, if your customers are signing 1 month to month contract, yes, they are most likely to leave. Like 88.6%, they are most likely to leave. So that's very high. So you don't want your customers to sign a month to month contract, right? So at least try to make sure that at least 1 year, but you can also see that okay, 2 years, you can see that the more you kind of like give them a longer contract, they're more likely to stay with you for longer, right? So this is self-explanatory. So we can see customer churn by internet service. So we can see that you probably want to go for you probably want to option for DSLL, right? So maybe these type of internet service are also correlated to cost, right? Maybe fiber is quite expensive compared to DSL, so that's why here you can see this, right? But one thing I can tell you is that you want to make sure that your customer kind of like uses DSL because it looks like they're not gonna churn if they're using that internet service, but if they're using something else 75% more, they're going to churn, right? So that's something that you should take into consideration. So let's look at payment method. So will they churn if they're using a specific payment method or some sort of like a streaming, if they're streaming movies and stuff like that, right? So let's try to look, and I'm just also gonna zoom in here. So what we're doing now is that, okay, we're asking ourselves question: what's the churn rate for what's this? We're trying to understand the payment method and the churn by streaming TV, and we also want to look at customer churn by streaming movies, right? So we're looking at these and just doing the same thing, just trying to understand the data. Okay. Cool. So let's continue. Can look at tech support. So what we're saying now is that does tech support, if we provide tech support to our customers, will they leave us? So we can pretty see that if like there is no tech support, our customer tend to leave. But if there is, then they're not gonna leave. So you can see that whenever there is no tech support, 83% they're most likely to leave. Okay, so that was the EDA. They say you must be one with data, so which means that you must understand your data before you move on, right? So that's what we did. we were trying to understand the data and just like look at it and just like trying to like understand what's going on, and but now we're gonna get to feature selection and engineering. So feature selection and engineering is whereby actually we want to select the features that, based on using statistical techniques, that we think are actually going to predict the target, right? And feature engineering means that we actually creating the features uh, based on another features. That's one thing that I can say, right? Okay, cool. Let's start with numerical columns, right? So let's look at the correlation and distribution of numerical columns, right? So I'm just going to run this code here, and let's do this so that we can actually see the plot that I have generated. So what I'll do is to actually paste it here, and I'll just zoom in so that we can look at it, right? It's popping up now. Perfect. So we're just looking at like the distribution of these columns, like tenacia. I think we saw it when we were doing EDA, and we can actually look at total charges. This is quite interesting. Look at total charges. We can see that actually whenever the customers are going to leave, so the correlation is quite high, right? We have 95 percent, I'll say. So, and no is 79. So it's also it's like it has to be close to 1, then that is high. Then if it's at 0, then there is no correlation. Then if it's at 1, then that's a negative correlation. Then if it's at -1, that's a negative correlation. Then if it's at 1, that's a positive correlation, right? So that's how we kind of like interpret these numbers. But we can see that the correlation here is sitting at 0.8. So total charges, very, very important. It's going to help us to explain the target, right? And monthly charges, the correlation is 0.2. And we can also see the boss plot, right? Like how they are distributed there. So we only have three numerical columns: tenacia, monthly charges, and total charges. So let's take a look at the categorical features. Okay, so we're just gonna run this. So categorical features, we're using this technique, chi-square test, right? So to kind of like look at the correlation. Okay, cool. So I'm just gonna run this so that kind of like show you the table. So look at this. Our contract, we saw this, right? Whenever we were doing our EDA, it was quite, we knew that it kind of like had a positive correlation with the target. It explained the churn that the customers are going to leave, right? And we looked at the payment method, paper billing. But we also saw that gender did not do so well, because we saw that actually it was fairly distributed, the data between male and female, right? So we can also look at the p-value there is very high, right? So it was supposed to be less than 0.05, right? So we can see that this is way, way, way too high. So we're going to discard these two values here, phone service and gender, because they're not explaining explaining the target that well. So we did like look at this is how you kind of like do your feature selection using these two techniques. Look at correlation for numerical data, and you kind of like look at the correlation. It also depends on what you're predicting, right? So sometimes there might not be a classification problem whereby your target is not a category like yes or no. It could be a regression like salaries, like house prices and something like that, right? So you should just keep that into consideration. So that, because now we did our feature selection, so we're just gonna remove all the features that are actually not going to help us that much, right? So we selected our features. We're just gonna go to pre-processing hyperparameter tuning, right? So what we wanna do when we get here, guys, is that we wanna start by splitting and resampling, right? What do I mean by that? Is that because we're going to train our machine learning model, so the first thing that we want to do is that to split it into training and test. So we're saying that the training set is going to have 80% of the data and the testing is going to have 20%, right? By strata, what do we mean this is that just be consistent how you kind of like whenever you're splitting the data, keep the distribution of the target, right? So let's say we know pretty much that the target is unbalanced, right? Meaning that we have more data of customers that did not leave us and few data that customer that left us, right? Maybe the distribution is around, is we can say between that yes or no, maybe we can say 70-30, right? So what we're saying with that is that if whenever you're splitting, just keep that distribution consistent, right? So cool. We're using resampling method just to avoid overfitting. So I did reshuffle my data here because it's the target was ordered, right? It started with no's and at the end it was yes. So I decided to kind of like reshuffle it. So we're not doing time series. The order won't affect us that much, right? So what we're doing also here, we kind of like doing cross validation. Like I said, it's a resampling method. So we created our fivefold, right? So I'm just gonna run these two guys here. Cool. So we're gonna start with pre-processing. You don't want to miss this one, guys. This is very important. So you know that data science, it's an iterative process, right? Like you can literally have multiple pre-processing steps, right? You can like normalize the data, do your dummy hard encoding stuff, and impute median, normalize it. Like there's so many stuff that you can do, like apply mode if you have unbalanced data. But the problem is, even if you do these complex pre-processing steps, you're not really sure which ones are actually going to help you. So what you want to do is that you want to create multiple pre-processing steps, right? Then you kind of like train them, all of them, and you look at which processing steps are actually helping you to kind of like get good predictions, right? So that's what I'm doing, and this is what actually R allows me to do. Like I really like this part, right? So these are my pre-processing steps, like doing one hot encoding, like imputing all the missing values and normalizing the numerical values like tenacia, monthly charges, and zero variance is just to say if we don't want a column to have a single value, right? So that's what we're saying. But I'm just gonna run this. So this is my recipe, but I also want to apply this technique smart, right? Because we have an unbalanced data. So whenever you have unbalanced data, what will happen is that your model tend to do good on customers who are not going to leave, but not so good on customers who are actually going to leave, right? Because you have unbalanced features. So you don't have a lot of data. So there's a lot of techniques that we can get into to work around that. Like you have to choose a good model. You can use like techniques like SMART. So what it does, it try to kind of like balance the data. So there's oversampling and undersampling, right? Like that's what's happening. So we also doing step correlation. So let's just continue. I'm just gonna prep the data so that you kind of like see what we just did, right? With those pre-processing, we can see that the values now don't quite make sense, right? Like meaning because that is because we have normalized them. So you can see that actually they have the same, they are on the same same distribution, right? So also we can see that the columns, we have one hot encoded them, right? Because new machine learning understand numbers. So that's why now all of these, there is no yes or no. So we have turned these things into 0 and 1s. Okay. So we're using XGBoost, and there's something that I want to raise, guys. Just keep this into whenever you're following along. So I inserted all of these numbers here after I have ran this code. So what this code does is that it found me the best parameters for me, right? So after then, I just place them here because I don't want to like guess the parameters. I want R to kind of like, R has this technique, Churn raise ANOVA, which you can use to kind of like find the best parameters for your XGBoost, right? Like trees, mtry, mean end, len rate, and stuff like that, right? So I've already that's why here you just have to say Churn. Then when you get all these best parameters, then you're just gonna replace them there. Okay. So I've already done that. I'm not gonna run this. This will take a while. So let's continue, guys. I've already run this model. So just to save some time, guys, I'm not gonna run this because it will take a while. But what I'll do then is just to show you guys the results, right? So just to kind of like give you the results of which model is actually doing great, right? Like it's giving us the model. But there's a thing. Let me just do this. I just want to explain this because this is very important so that you will actually see what I meant by, let's say as a data scientist, you have a lot of pre-processing steps, right? So what R allows you to do is that you can now get predictions, right, for all the metrics that you want to see, and you can actually plot those metrics results against the pre-processing steps that you had. So we can pretty see that the first one here, we have sensitivity and specificity. So we can see that it's actually 90%. And when we then, because we use the different pre-processing step, like the one is Churn recipe, and the one whereby we apply the SMOT to kind of like, because we have unbalanced data, to kind of like balance it. And we can see that when we go to specificity, our model tend to do better whereby we apply the SMOT, right? It's giving us, it's doing better than the model whereby it's doing better than the processes whereby we did not apply the SMOT, right? So we are around like 50%, and where we apply SMOT, we are around 70%. But that's the thing. There's a trade-off. You can see that if we don't apply the SMOT, our sensitivity tend to be higher, right? It's around 90%. But immediately when we apply SMOT, it reduces to, you can say 55%, 54%, right? So it's not that good. So this is a trade-off. But there's a trick. You have to understand the business because that's the determining factor, right? Do you want to predict the customers who are going to leave, or you want to predict the customers who are going to stay, right? So that's why we're gonna have to look at conversion metrics. So because like that's when you go into actually understand if you have to like make sure that like you kind of like improve your specificity or sensitivity, right? As long as you understand the business. But in this case, in our problem, we know that we actually want to make sure that the customers, we want to predict the customers who are going to leave, right? The customers who are going to stay, they're going to stay, like it's not going to cost us that much. So there's a trade-off. That's why I'm saying it's important for you to understand. Okay? Let's look at the training and evaluating, right? So this is the final step, guys. We are getting close to ripping this, right? So now, because of we train our model, like we know the parameters, we know the model that is going to do good. So what I did was to actually do this. So I just said rank results. So I knew that which process was doing good and which model was doing good. So, but like I said, this is not a good model from business perspective, because business does not want to predict customers who are going to stay. Customers who are going to stay, they customers who are going to leave, that's a cost, right? So you might want to use a model that is doing good when it's predicting on uh customers who are going to leave, right? Specificity. So you want to make sure that you get a model that is doing good on specificity. Okay. So in this case, we didn't choose that, but that's what you want to do, probably based on business need. So we're just going to collect the metrics. Also just gonna, okay. So what I'm doing here, I've just trained the model. So this might take a while. Okay, it's done. So getting the accuracy and we're getting the sensitivity. So you can see that the specificity is bad, right? So that's why I said you might want to choose the model whereby you're doing good on the specificity, right? You're getting over probably 80% or so. Then the sensitivity we're doing well, 90%, right? So just keep that in mind. But the goal here is not just to get the perfect prediction, but just to show you the end-to-end machine learning data science lifecycle. So this is a conversion matrix. So let's look at feature importance, right? So this is like all the features that were quite actually important towards model making prediction, right? Or getting the higher accuracy, right? So we can see that the contract, whenever it's month to month, actually that is pretty powerful, right? Like it's helping our model. And we knew whenever we were doing EDA that I think it had something like 86%. It was actually predicting that the customer is going to churn. Also, Tenasia came second. So we also saw that during our EDA. So also total charges. It's quite predicting. It has like more important towards model making good predictions, right? So what I want to do now is just to show you like results interpretation, right? So this is like a way of machine learning saying, how did I reach these predictions, right? Why did I say this customer is going to leave? So we just chose a random customer. I think is what it was on row 5,000. So we just took this customer here. So we can actually take a look at the features. So ID 42. So this is their features. And we can see that whenever internet service had a more contributing factor towards the customer leaving, right? So at the internet service was 3. So we know that 3, I think it was fiber optic, right? That is very we know that whenever it's fiber optic, like whenever the internet service is fiber optic, that tend to make customer churn. That's why you see there internet service like had a more contributing factor. So also contract, look at it. It came second. So we know that whenever contract is month to month, that also has a contributing factor. Let's look at this. Yes, it is month to month, right? So that actually kind of like pushed the prediction towards what machine learning came up with, right? So what I finally did was just to save the model into the repo, and yeah. So I think what I want to do, guys, is that I'm thinking of actually because I can see that this video is gonna be long. I'm thinking of actually making a part 2 whereby I walk you guys through the Plumber API, then I cover the React application. So and how we kind of like build this with React, right? Because I don't want to make this one to be long. So I think that'll be good, right? So let's just make our final prediction. Like I said, guys, I'll just make part 2 for those who are interested in the React part, and the plumber part I'll just make part 2, but I'll still share the code in the GitHub repo for those who just want to replicate everything, right? So let's just go to the database and just get a random ID in there. I think we can actually just to make prediction on any random customer, right? So let's actually use this one here. Cool. Let's just go to the application. Just gonna paste this. Get prediction. Oh, our R server is not running, right? Because we did not run the plumber API. So we just need to start this guy. So our plumber API is running. So let's say get prediction now. Perfect. So we can see that this customer is predicted as they go into Churn, and we can say get me the probability of SG boost, right? So we can see that the probability is 0.5. So let's see if like we try to increase their contract, right? See what does that like it shows like now I'm sure you guys actually understand, like we saw when we were analyzing the data, what month to month does to the model, right? Like we know that it kind of like makes the customer to leave. So it's important kind of like understand this stuff. But that's all, guys. I really appreciate you guys for if you did watch to the end and for tuning in. I really appreciate it, guys. So we're gonna look at the part 2 when we go through the React application and Plumber API. Thanks, guys, for tuning in. See you in the next video. Bye.